Hello, this is Robert Casey, and this is a presentation on statistics of YDNA analysis. About half of this presentation will be on YSNP prediction and the models that are created, and then it'll cover also briefly some aspects of statistics for charting, and it will also go over in quite detail family tree name match list and the issues associated with those lists. First, let's give an overview of YSNP prediction. YSNP prediction has to be in the 1500 to 2500 years before present time frame, because if it's any older, then there'd be too many hidden mutations to give for SDRs to actually see and live in testers. And if it's any younger, it wouldn't have enough time to develop robust signatures. YSNP prediction uses binary logistic regression, which is the best choice. You can buy a software package called AccuStat for only $10 plus tax, and this is a very easy product to use. YSAP charting uses both YSNP data and YSDR data, and it uses predicted data of YSDR only testers that have been predicted by fully tested YSNP testers. Also, this will cover family tree name YDNA match list reports and why a lot of the error rates are 50% versus the expected 5%. There are four factors that make YSNP prediction more accurate. First of all, they have to be in the right time frame. The second aspect is you need some genetic isolation from the YSNPs. You really need about 10 to 15 branch equivalents in the two highest branches of the haplogroup they're analyzing. Also, you need genetic isolation for YSDRs. So you need a signature at least 7 markers, and sometimes it can actually go up to 14 markers. Also, the sample size. It just won't work for very small groups. You need 50 to 100 testers. That includes both confirmed and predicted testers, and also you need about 10 to 20 YSNP branches as well. So why is the time frame important? First of all, you have to understand that you use the modal values for some very old haplogroups that are very broad. These are around in the 4,500 year time frame ago, such as RL21, P312, and U106. These are all well-known, very large haplogroups, and you look at the modal values, which is the commonmost values, and use that as a starting point. Predictable haplogroups fall in a much younger time frame of 15 to 2,500 years before present. So that gives you between 2,000 and 3,000 years to develop a good YSDR signature. Due to the mutation rates of Y67 markers, any older haplogroups older than 2,500 years ago just have too many hidden YSDR mutations. Also, I ignore CDY markers because they may just mutate too fast for this time frame. However, surname clusters form around 1,000 years ago. This only leaves about 500 to 1,500 years to form much smaller signatures. Also, YSDR signatures for surname clusters, which is what most people are interested in, they generally just have 1 to 3 markers the vast majority of the time. It also is a good important factor that you have genetic isolation with YSNPs as well. And this is done by picking a YSNP branch or a predictable haplogroup that has at least 10 to 15 branch equivalent in the top 2 branches of the predictable haplogroup. This provides just genetic isolation of the YSNPs, and this is just a secondary isolation, including the SDRs. Surname clusters rarely have any or very few branch equivalents, so that's an issue of isolation in that time frame. You also need YSDR genetic isolation. Most predictable haplogroups have between 7 and 14. If you go below 7, you better have very strong other factors going for you. Otherwise, your accuracy will suffer a lot. And for just random statistical variation and the age of your haplogroup, sometimes you get up to 12 to 14 mutations in your signature. This provides genetic isolation for your YSDR mutations for predictable haplogroups. Surname clusters rarely have more than 5 markers, and on the average for L226, there's only 2.2 markers for the 28 surname clusters. And this is now over 41% of all the testers under L226. Sample size is another key factor. Predictable haplogroups are becoming larger and larger, and there are just much more that are now hitting this critical portion of a requirement, which is sample sizes. It's very common for people to find 50 to 100 YSDR testers in any predictable haplogroup these days, and 10 to 20 YSNP branches. There are now hundreds of these under haplogroup R, so it's very common these days. So as projects get bigger and bigger, the accuracy goes up. However, most surname clusters only have 5 to 10 testers, but few of these do have 50 to 100 year range. But the genetic isolation, both for YSDR and YSNP, is so bad that the sample size just can't make up for the poor genetic isolation. I will cover 5 of good examples of under L21 of very large haplogroups. These are M222, L1065, which is 95% of L1335, Z255, L226, and L371. All these have very nice projects that cover these particular haplogroups. These represent the most projects with over 100 testers in the project. CTS 4466 is another one, but I haven't updated that in a while. And I just completed a review of L1280, which is under haplogroup R1A, and it works pretty well as well. Unfortunately, there's another 45 haplogroups I've done that don't have projects, and this is a serious problem, and we need more volunteers to do admins on these predictable haplogroups. Here's a summary of these 5 haplogroups. First of all, they all start with L21, which is 4,500 years ago. So the years to form signatures is quite large. They vary from 2,400 to 3,200 years. That's a long time. So you can get good genetic isolation on that time frame. M222 has 35 branch equivalents and a signature size of 11, 964 testers, and it yields a 99.9% accuracy with only one outlier not being predicted properly. L1065 is another big one. It has 17 branch equivalents, but the signature is only 7, but with a very good sample size of 672. It has a 99.6% because the signature is only 7. Then you have Z225. It has a bunch of branch equivalents, but the signature is a red flag because it only has 5, which is below 7, but it has 500 testers, but it still has 98.2% accuracy. Then my particular haplogroup that I analyze has a signature of 9, 25 branch equivalents, 581 testers, and it has 100% accuracy. And L371 is a much smaller one. It has 9 signatures as well and 37. So it's very isolated, but it only has 45 testers. But it also has 100% accuracy as well. I'll cover skewness and kurtosis in a later portion of this presentation. To understand what's really going on, you have to see the curves of genetic distance and the spread of them to see if this is really a normal curve. And there are 2 measurements for normalcy of curves. One is skewness and one is kurtosis. The skewness of 0.78 is a pretty significant problem because anything over 0.5 is considered skewed to a certain nature. Not real bad, but skewed. When it has a plus sign, that means it's a positive skew. It means it's skewed to the right side. What that means is the chart is stretched out on the right side. That's what skewness means. Kurtosis is a measure of outliers primarily. And since it has a positive number, and it's fairly high too, but it's still within the acceptable range, those represent the higher GDs that are kind of skinny tails sitting out there on the right side of the curve. Next you have M222, and it looks more like a normal curve, but there again it's slightly skewed to the right, which almost all haplogroups are. And the kurtosis is also very small, so it's a very acceptable range as well. So why do you do YSNP prediction? First of all, you need to have valid data if you're going to analyze. And if you're going to chart these things, if you just introduce a small 3 to 5% of bad data, your chart's going to get way off. So the best thing that YSNP prediction does is it collects reliable input to your analysis. Also, it is very important to collect data. And so you can use a model and it'll automatically come back as 1 or 0, and it takes the guesswork of what belongs in your haplogroup and what does not. Then charting, which is another form of prediction, uses YSNP data to develop YSTR signature, and these develop patterns of YSTR signature mutations called YSTR signatures. And then also you can develop surname clusters, and surname clusters need to have at least 5 testers, and any particular branch you cannot exceed the 50% MPE rate, because that's about what the maximum allowed over the last 1,000 years since our ancestors started using surnames. These 3 sources of data are far superior to raw genetic distance, such as the family tree name match lists. So next I'm going to go down to the surname cluster level. And this is for my Casey surname cluster, which is identified by FGC 5647. There are 21 testers, and this is not a whole bunch, but it's one of the larger ones, the top 3 or 4 under L226. There are only 3 testers with the surname that are not with the surname Casey surname. So that's only a 13% MPE rate. So this is a very solid surname cluster. Any branch must have less than 50% MPEs to be included. The father of 5647, which is Z34_1, that is its father. There are no Caseys in there, so there can't expand the scope of the Casey surname cluster because there's none in that level. Also, there's 7 brothers of FGC 5647. None of those have Caseys in them. So we found the scope of this particular surname cluster. Here's a manual chart of the surname cluster, and I won't go too much detail there, but there's 2 purple boxes in the middle and the top. The top is FGC 5647. That's the beginning. And then all but 3 testers also test positive for another YSNP branch, 5639. The other 3 testers between those 2 are quite old. Everybody below that are believed to have migrated from Ireland to South Carolina around 1750. But there's 3 interesting testers up above. One is a Casey who's in the mid-1700s in Pasquotank, North Carolina. And then another guy, a Benton guy, who's in the same county in the same time frame, probably an MPE of the Casey. And then we have a real interesting one on the right, which is a Kersey. This guy was in Oxford, England in the early 1600s. He probably took his Casey surname and converted it to Kersey, which is an acceptable English surname to avoid being persecuted as being an Irish person. But what's not in here is that all the Ancestry.com shows lots of connections to Virginia, South Carolina, between the Virginia Caseys and the South Carolina Caseys. And guess what? All the Virginia ones aren't related genetically in the last 3,000 to 4,000 years. But you still see all these charts being propagated throughout the internet. Here's a chart produced by SAP. This is an HTML version, and it shows you the progression of YSNPs and YSTR mutations. And this is a pretty solid Fitzpatrick surname cluster being developed. There's 9 testers. 8 of them are Fitzpatrick. One's a Fitzclarence, which probably is a Fitzpatrick MPE event. But then there's 4 Creightons, 2 Rileys, and 1 Ermold. So it's below the 50% MPE rate, And this is, may or may not be, as time moves on, some of these might move out and some more move in. But this is always a surname cluster that's very close to being formed. So I'm going to dive into 3 surname clusters under L226. The largest ones is the O'Brien. It has 71 confirmed and over 100 both confirmed and predicted. And then the Kennedy has 13 confirmed testers, and the Casey, which we just went over, has 9. But the Casey surname is unique. It has a 5-marker signature associated with its highest YSNP branch. And it also has 8 branch equivalents, so that's very good genetic isolation. However, the Kennedy and O'Brien surname only has 1 marker and virtually no branch equivalents in the branch that starts the surname cluster. Here's a chart of the O'Brien surname cluster, and this looks more like a fairly normal curve. Once again, it does have a skinny tail on the right and a little tail on the left, but with such a small sample size, this is expected. But it does appear to be somewhat of a good normal curve. But then you look at the Kennedy surname cluster. Wow, this is very different. This looks nothing like a normal curve. It doesn't have the hump in the middle and the bell curve on the lips on the sides. It's just really flattened out. The high value of kurtosis says this is way too flattened out, and so this is not a good normal curve at all. The Casey surname cluster also is not very good. It has a very high kurtosis of 2.8, which is, in some circles, is rejecting as a normal curve. It does have a hump in the middle, but it has no tails. And because it's a negative number, it's saying it's very, very flat and much not high enough and doesn't have any semblance of a bell curve. So this is not a very good normal curve as well. But the problem with these surname clusters is the years for the signature to develop. It's only 1,500 years for L226. So between that and our surname creation, it's only 500 years. That's just not enough time to develop signatures. And the Kennedy and O'Brien show that, and statistical variation just assisted the Casey to actually have a good, not as good as 7 or 10, but does have a strong 5-marker signature. So now we're going to dive in and just show how bad the family tree name match list misses out. And what this is this the O'Brien surname cluster, which has 102 testers, which is a very large surname cluster, probably in the top 10 in the world. And I'm taking just one tester for each GD, 1 through 7. And of course, the lower ones and the higher ones don't have very many, but I just randomly picked one. And so the first guy who GD1, he has 737 matches, but there's only 102 testers with charting. So he has an 86% false positive rate. And at 2, it goes down to 586 matches. So the next guy at 2, and he's at 83%. And then at 3, only goes down to 389. That's a 74% false positive. And even at 4, it's 229, so half of them are wrong. So this is much, much higher than the 5% assumption of the error rate that family tree today is supposed to be returning. But then when you get down below, further down at the higher genetic distances, it only has 67. So now you're getting a 34% false negative because it's not showing everybody. It's declaring 35 of those testers as being negative. And at 6, you're having a false negative of 27%. And at 7, there's only 2 testers that match within the surname cluster. And that's a 98% false positive rate. So it's saying that only 2 O'Briens are related to them, even though we know from YSNP branches and YSTR branches that this is not the case. And it's consistent with the Kennedy as well. It's 27 testers, much fewer, so I did 3 to 8. and it has a 94%, a 91%, a 73% false positive, because it's given, multiple times the matches that are actually in the surname cluster. That flips over to an 89% false negative for one tester at a genetic distance of 6, and then a genetic distance of 8. It didn't show anybody's matching, so that's 100% false negative. So that's a problem. But then we look at the Casey surname cluster. This one only has 26 testers, but and there's only two showing up, genetic distance of 7 and 8. So that's quite high. And look at the numbers. 23 out of 26 and 25 out of 26 are being predicted correctly. So this is only 11.5% and a 4%. So this is getting close to the 5% range that FTDNA uses. But this is only because this has a signature of 5 and 8 branch equivalents, which is pretty rare for surname clusters. There are now 28 surname clusters under L226, and 402 testers are assigned out of the 976 testers. That's 41% of the testers are now under surname clusters. However, the average signature under L226 for these is only 2.2 markers. That's a real problem, because that's just not enough genetic isolation on the average to really depend on genetic distance of any kind of indicator of relatedness. But if you look at the curve of genetic distance for L226, let's just take the O'Brien and Kennedy. They have signatures of just 1. And once just say that signature is unique, which it probably isn't, that would just shove the whole curve to the right by 1 for either the Kennedy or O'Brien. And so look how many matches you're going to have up to 5 and 6 and 7. They're just way, way too many. So when you have very low signatures and lots of testers showing up in low genetic distance, that's a recipe for very poor raw genetic distance doing any good. So why is this happening? This is a chart by David Vance, and this is one that I really just love because it really explains things. So if you're Genghis Khan and had 100 sons and they all had 1 son each, you would have 400,000 branches across 4,000 years. That's 400,000 generations. Each generation is possible for mutations. Now let's say that you are just Genghis Khan and you just had 1 child, 100 sons, and look what happens. It goes down to 4,000 again, basically. So it's 100 times more mutations. So the number of branches helps. So what the problem is that in the early parts of the branches, there's not many paths. And what happens is because there's not many paths, there's not many generations to mutate. So that's why our proportions of the tree have very low numbers of mutations. But the bottom parts of the trees, you go from 10 branches or 10 paths in one time frame to 50 to 200. By the time you get to every person, you have a branch for all 1,000 testers. That's 1,000 branches. And so that's a lot of mutations can happen across 1,000 different paths. So what kind of conclusion can we draw? First of all, YSNP prediction removes bad data from getting your analysis. It also provides a very convenient and automated way to determine who belongs to your haplogroup and who doesn't. Charting using YSTR signatures is far superior to YDNA, family tree DNA's raw genetic distance match reports. They're good for recruiting, but they're not good to show you how closely people are related because it doesn't show you what you should be seeing, and charting does. Charting uses 3 components. It uses YSNP data, which helps filter out a lot of the statistical variation that involves with YSTRs because they can mutate back and forth over time, and they can mutate independently all over the place as well. Surname clusters reveal what genealogists want to know. They want to know who's related to me in the last 1,000 years. My surname was created if you have Irish ancestry. The family tree name matches just are not reliable, but they are very useful for recruiting project members because they give you direct access to your matches email addresses. Here are several links to other YouTubes I've done. One is how do you determine your predictable haplogroup? These are the characteristics and goes through step by steps. There's four characteristics you have to develop, and not everybody will have these, but it will give you a step-by-step analysis of how to do that. Also, you need to create your own Excel spreadsheet, and this shows you the basics of what should be in the spreadsheet and why they should be in the spreadsheet. And also, it's better to create a haplogroup project and encourage people to join, talk to the people in your in posts. It's just a better way to communicate and gain more interest. Also, there's another presentation on what exactly is a YSTR signature, how it works and where it does not work. And then if you wanted to dive in more deeper on the details of YSNP prediction, there's another one. And then also give a step-by-step prediction using the AccuStat. I'll stick one step at a time of how to create a spreadsheet and import AccuStat to get the constant to create your own binary logarithmic model. This product only costs $10 plus tax. So the top chart or presentation shows you more details of the mechanics of how charting works. And then if you want a step-by-step for knowing how to do charting with SAPP, this is another one. And the next one is an older version of this presentation, which really probably has limited value because this presentation is I've learned a lot in the last few years. So, and then you get the privacy versus accessibility. This is just accuracy on statistics is based on sample size. Half the people are private these days, and that's just killing accuracy because if we had twice as much data, there'd be twice as many predictable haplogroups out there. And if you want to get a link to AccuStat to see how you download that. And then I did another presentation on very larger predictable haplogroups. There's only probably a dozen of these under haplogroup R today. You can actually get very, very accurate TMRC estimates between the formation of the haplogroup and all the surname clusters. And then also, if you want to look at my chart for L226, this is approaching 1,000 people. It takes over 100 pages. This should show you in detail what people want to know is how they're all related to each other. This is like a box descendant chart.